Imagine a power plant the size of a city, not rising above the landscape, but hidden deep inside a mountain. This is not a concept drawing or a futuristic experiment. It already exists. Carved more than 300 meters beneath solid rock, this is Asia's largest underground hydropower megaproject. A machine built where gravity, pressure, and geology work against every decision. What stands here today is a reminder that some of the world's most extreme engineering happens where no one ever sees it. Please take a moment to subscribe and like the video. It really helps the channel. This project is the Baihetan Hydropower Station, built along the Jinsha River, the upper reaches of the Yangtze, on the border between China's Sichuan and Yunnan provinces. At first glance, the site gives little away. The dam dominates the river, rising 289 meters high, making it one of the tallest arch dams ever built. But the real megastructure lies behind it, buried inside the mountains on either side. This underground complex supports a total installed capacity of 16 gigawatts, placing Baihetan among the two most powerful hydropower stations in the world. Building underground was not a stylistic choice. It was a necessity. Placing the power station beneath the mountain reduces environmental impact, protects critical infrastructure from surface hazards, and provides natural containment against immense water pressure that can exceed 10 megapascals at full operation. It also allows the plant to operate with greater stability in a region shaped by steep valleys and high seismic risk. But hiding a power station of this scale creates challenges unlike anything above ground. Before a single turbine could be installed, engineers had to remove over 25 million cubic meters of rock. Excavation pushed deep into some of the hardest basalt and granite formations in the region. Conventional tunneling methods were not enough. Controlled drilling and blasting operations were carried out around the clock, advancing sometimes only 1 to 2 meters per day to avoid destabilizing the surrounding rock mass. As the caverns expanded, the forces acting on them increased dramatically. Rock pressure squeezed inward, groundwater seeped through microscopic fractures, and temperatures rose beyond 40 degrees Celsius in confined spaces. To counter this, engineers installed more than 100,000 rock bolts, steel reinforcement ribs, and layers of sprayed concrete to lock the mountain in place. The resulting underground complex spans several kilometers of tunnels and caverns, large enough to house turbine halls over 80 meters high, transformer chambers, access shafts, and ventilation systems, forming a complete industrial city beneath the surface. Geology quickly became one of the project's most serious adversaries. The Jinsha River corridor lies within a tectonically active zone where faults continue to shift by a few millimeters each year. Engineers carried out high-resolution geological mapping across the entire site, identifying dozens of fault lines and fracture zones before final tunnel alignments were approved. Where unstable rock could not be avoided, reinforcement densities were significantly increased to withstand both constant pressure and potential seismic shocks. Groundwater posed an equally serious threat. Under high pressure, uncontrolled water inflow can erode rock like a cutting tool. To manage this, engineers built extensive drainage galleries inside the mountain, releasing pressure gradually and safely, diverting water away from critical infrastructure. Every stage of excavation was monitored in real time, turning construction into a continuous negotiation between human design and geological reality. At the center of Baihetan lies its Turbine Hall, one of the largest underground power caverns ever constructed. Inside, 16 massive Francis turbines, each rated at 1 gigawatt, convert the force of falling water into electricity. Each turbine assembly weighs more than 8,000 tons, rotating under carefully controlled hydraulic conditions. Water enters from the reservoir through pressure tunnels carved deep into the mountain, accelerating as it drops more than 200 meters toward the turbines. Flow rates exceeding 700 cubic meters per second per unit are precisely regulated to maximize efficiency and prevent destructive cavitation. After releasing its energy, the water exits through tailrace tunnels and returns to the Jinsha River, completing a cycle driven entirely by gravity. With a total generating capacity of 16 gigawatts, Baihetan can produce over 62 billion kilowatt-hours of electricity each year. That is enough to supply power to tens of millions of households, primarily in China's eastern industrial regions. Electricity generated deep inside this mountain is transmitted through China's ultra-high voltage network, with lines operating at plus or minus 800 kilovolts, moving power efficiently across distances of more than 2,000 kilometers. This output replaces an estimated 20 million tons of coal annually, reducing carbon dioxide emissions by more than 50 million tons every year. To ensure reliability at this scale, Baihetan integrates advanced monitoring systems that track vibration, temperature, pressure, and microscopic structural movement in real time. Artificial intelligence supports predictive maintenance, identifying irregular patterns long before they escalate into failures, allowing the plant to operate near peak efficiency for most of the year. Earthquake resistance was not optional. This region has experienced earthquakes exceeding magnitude 7 in recorded history. Instead of resisting seismic forces directly, engineers designed the underground caverns to work with them. The surrounding rock mass acts as a natural shock absorber, reducing peak stress loads on concrete linings. Massive structural segments are connected with energy-dissipating joints that allow controlled movement during seismic events. Turbine foundations are vibration-isolated to prevent resonance damage. In this design, the mountain itself becomes part of the safety system, turning geological risk into structural protection. At Baihetan, water pressure reaches levels rarely managed at this scale underground. Pressure tunnels and penstocks are shaped with millimeter precision to reduce turbulence and energy loss. Pressure relief shafts and surge chambers absorb sudden changes in flow during rapid load adjustments or emergency shutdowns, preventing damage to both tunnels and turbines. Engineers simulated extreme scenarios, including 100-year floods and sudden grid disconnections, long before the first turbine ever spun. This preparation allows the plant to adapt not only to seasonal river changes, but also to long-term climate variability. Baihetan is designed for an operational lifespan exceeding 100 years. Cavern linings are reinforced to resist long-term creep in the surrounding rock, while corrosion-resistant alloys protect turbine components exposed to constant water flow. Modular turbine design allows future upgrades without dismantling the core underground structure. Over time, this plant will function as a stabilizing anchor for regional energy supply, supporting industrial growth while maintaining low operational emissions. Its longevity turns it from a construction project into permanent national infrastructure. The impact of Baihetan extends far beyond its power output. It represents a major step in Asia's renewable energy transition, demonstrating how large economies can decarbonize at speed without sacrificing grid stability. Construction techniques developed here are now influencing underground pumped storage facilities, transportation hubs, and deep infrastructure projects worldwide. What engineers learned beneath this mountain is shaping how future cities may expand downward as surface land becomes increasingly limited. Behind every tunnel and turbine is a workforce of thousands of engineers, geologists, and construction crews operating under extreme conditions. Many worked shifts lasting 12 hours or more, deep underground, surrounded by forces that cannot be switched off. Their success reflects decades of accumulated expertise refined under real-world extremes. Baihetan stands as a reminder that some of humanity's greatest achievements are invisible, silent, buried, yet essential to modern life. As cities grow and space becomes scarce, Baihetan points toward a future where infrastructure expands below the surface as much as above it. This project is not just a power station. It is a proof of concept, a demonstration of how engineering can turn mountains into machines and depth into opportunity. Deep inside the rock, Baihetan does not just generate electricity, it redefines what infrastructure can be when engineers dare to build where few ever will. Thanks for watching Unthinkable Build. We'll see you in the next one.